Right. So, chapter 2 is on system models and networking, internetworking in general. This is a chapter for which operating system and networking come together, starting with number one, question number one, an easy one. It says provide three specific and contrasting examples of the increasing level of heterogeneity experienced in current or contemporary distributed systems. So as far as a system being heterogeneous or dissimilar or diverse in elements, i.e. hardware and software, so this is concerned with hardware diversity, operating systems, network, and programming languages. They could all be different. So for the examples, they relate to the first, hardware. So in terms of hardware, distributed systems are, as you should know, increasingly heterogeneous, and they do feature, in general, Intel-based PCs, smartphones, as the one Quinn is using now, Quinn Ling, although you cannot use a smartphone, you will have to use your laptop, as I said. Anyways, resource limited sensor modes, such as wireless sensors networks, and resource rich cluster computers. Remember, cluster computers, i.e. The partitioning of networks into smaller pieces, and they are all connected via proxies, routers, gateways, and what have you. Again, the use of multi-core processors for parallel processing if needed. So as far as the examples concerned, this is concerning the hardware. For the operating systems, a distributed operating system or distributed system should include computer running, say, for example, Windows, Mac, and Linuxes as in different flavors of Linuxes and Unixes. And more specialist operating systems for your own smartphone or sensor modes, such as the one I mentioned, WSNs or WSN, is wireless sensor networks. We covered this, if you remember, in the 530. And lastly, the topology concerning networks. So in terms of networks, the internet is also increasingly heterogeneous, different topologies, i.e. star, hub, mesh, and what have you. Also embracing wireless technologies and ADAC style, i.e. those networks that come and go depending on the need, ADAC networking. So those are the three main issues concerning heterogeneity as far as the construction, the structure, the architecture of your distributed system. Question number one. Do we have a question on one, people? Question number one. Do we have a question on one? Yes, Kuta. Of course. It says, if you look at operating systems, it says Mac. Could you look to the second point for the example? are you talking about the question? If you are talking about the question, look at the Kuta. Look at the second example, operating systems. Can you see that? Okay. Right. So we'll move to number 2. Again, an easy question. This is just 1 and 2 are actually 1 and 2 and 3 are just introductory to the chapter. So it says, what problems do we foresee, or do you foresee in the direct coupling? Now, coupling and uncoupling, again, coupling and uncoupling, this is related to dependent and independent, i.e. coupling dependent and uncoupling independent. So what problems do you foresee in the direct coupling between communication or communication links or communicating entities that is implicit in remote invocation approaches, i.e. Things that you have to control remotely, let us say control messaging and so on. And then it says, consequently, what advantages do you anticipate from a level of decoupling, i.e. some sort of independency, as offered by space and time uncoupling. Space as in distance, time as in synchronization. Again, space as in distance, time as in synchronization. Right. So the client is inherently or intrinsically bound to the server, obviously, and vice versa. And this is inflexible. This is due to the bounding between those two time-wise in terms of dealing with failures. So if one fails, the other will be affected. So for example, if the server fails and a backup server takes over, managing requests of those clients, more generally, this level of coupling makes it hard to deal with change. And the change here relates to the on and off, i.e. The bootstrapping of users, because users tend to come in and out, and this will affect the topology size, scalability, requirements, and obviously updating. Second, clients and servers must exist in some form of a confinity, i.e. they must exist at the same time, so either they are there or not, and hence it is not possible to operate in a more volatile environments, such as when either party may be unavailable, so they must be confined, okay, in a set or even a subset. Remember, if we are using cluster or clustering, this is applicable. Again, for example, a disconnected user in the case of a mobile node. You see, mobile nodes, they come in and out depending on the roaming technology. Again, depending on the roaming technology. Third, the benefit of scalability or space uncoupling is in providing more degrees of freedom. Remember, uncoupling refers to independencies. Such freedom in dealing with change, for example, if a new server starts dealing with requests or new requests. Also, the benefit of time uncoupling, i.e. The shareability. So the benefit of time uncoupling in allowing entities to communicate when entities may come and go. Remember, this shareability. These time slices must be shared in the vicinity of how many users or nodes are currently under that management of a server. So they do come in and out at leisure. So you have to provide for such uncoupling requirement, which will benefit time-wise or time slices, so the system performance will be directly impacted. Space and time, or space slash time, again, they refer to scalability slash synchronization. Question number 2. Do we have a question on number 2? Anything on question number 2, people? So what is the advantages of coupling then? Well, if you have a confined organization, Kim, if you have a confined organization, i.e. an organization for which requirements are somehow standard or set, such as the intranet. Kim, such as the intranet. The intranet is a good example for coupling. Does that answer your question? Again, intranet, not the internet, the intranet. Okay. Question 3 is left for you to dwell in. This is just a relation between applications related to distributed operating systems. So it says, explain how a distributed operating system may manage an internet-based applications. And there are so many. This is a general question. It is just a recap on question 1 and 2. I just put it there for your own benefit if you want just to recap on application-based. Mind you, you as computer science students, most of you do work, such applications are known to all of you. But then again, it is just put there for completeness. I'll jump to question number 4. And now this is touching some heavy stuff. Right. It says for applications such as web, mail, and net news, what placement strategies or what could be done? What placement strategies, what could be done? What placement strategies are employed in implementing the associated services, i.e. the linked slash organized services. Okay, now for each one by one, for the web, now remember with web pages, think about updating. Think about updating. So web pages or web page masters are held in a file system in a single server. Okay, so the information on the web is therefore partitioned, and this is important, partitioned among many web servers. This is concerned with load balancing. Again, this is concerned with load balancing. Right. Replication, therefore, is not a part of the web protocols. But, and this is a big but, a heavily used website may provide several servers, obviously, with identical duplicates or copies of the relevant file system using one of the well-known means for replication. Okay, now this replication obviously must be done in terms of updating those in a timely manner. That's why you see the word slowly. Slowly means that updating is done in a timely manner, as an update is to be spread among a related web page. Obviously for data change or changing data. HTTP requests can be multiplexed among the identical servers using IPs or the basic DNS load sharing mechanism. This is again for the purpose of load balancing. Also, web proxies or routers. Web proxy service support replication using memories or using cached replicas of recently used pages. This is as opposed to slowly replicating or updating the pages as seen before. So those browsers should support replication by maintaining a local cache of recently accessed pages. So in essence, we are talking about updating. How updating is done. This should be done in a timely manner, and this should be done slowly. Slowly in terms of an update should be done periodically. Now for the mail, messages are stored only at their destination once they received, obviously. That is, the mail server is based mainly on partitioning, although a message to multiple parties or recipients is replicated at several destinations. This is to do with how the messages are sent speed-wise or time-wise. This is just to accelerate the spread. And lastly, as far as the net news, each group is replicated only at sites requiring it. Because as you know, the news or news updating, it is dependent on a particular service that offers a related news, i.e. sports, political, social, and what have you. So the last one, as far as the net news, are a little bit different as far as the spread and as far as the type and how frequent updates are to be done. All in all, just to wrap up an answer for this question, in terms of caching and proxies, this is related to the cache servers. Okay, so web servers cooperate with proxy servers, those cache servers, to minimize network traffic. Remember, speed, right? And latency. So responsibility for consistency, i.e. updating, responsibility for consistency is taken by the proxy servers. Okay, so it is their job for that update to be done promptly. They do check the modification date of a page. This is, remember the term slowly. Now there is a counter that will look at the time, okay, date, time of that page, and on that updates are to be maintained. The web also features significant use of mobile code. As an example, through AppleNet. Now, what is AppleNet? This is an external package, which is a program designed to be executed from within another application. Okay, external package, where code is downloaded and run in the browser machine, your own browser machine. So this is an external package just to help things to be organized and well maintained. Question number 4. Do we have a question on 4 people? Do we have a question on 4 people? Okay. 5, crawler usage or the use of crawlers. 5 is also based on updates and how updates are actually maintained. It says a search engine, which is by definition is a web server that responds to client requests to search in its storage database. Okay, and it's stored indices and concurrently run several web crawlers tasks to build an update of that indices, i.e. increase its knowledge. This is relating to the increase of the knowledge of that particular search engine. Now the question is, it says, what are the requirements for synchronization, timing, between these concurrent activities? Don't forget, while we're doing those activities, we might be needing to update. Apart from the update, we need to increase the size of this search engine as far as its database. So back to the crawler tasks. The crawler tasks, which relates to the spreading the load of tasks across many computers. Now, spreading the tasks does not mean that those tasks are spread equally. It will depend on how heavily accessed that search engine is. They could build partial indices to new pages incrementally. Remember, if knowledge is not there, it is added, searched for, and made ready for the next user or client. And then merge them with active indices, i.e. current indices or index, including deleting invalid references. Invalid references refer to pages that are no longer there, indices that were put out of context, and what have you. Now, the merging process or this merging operation could be done in an offline copy, i.e. a part of the system being active for the passive or the passive side of that server or that search engine is in that operation or the merging operation. And finally, the whole environment or the environment for processing client requests relative to obviously the search engine is changed to access the new index because it is updated now. It is available. The latter might need some concurrency control because it is a new, right? No concurrency control, i.e. Making sure that it is available not for that client, should be available for any. In general or in principle, it is just a change to one reference to the index, which should be small. Now, it is small because you are talking about large number of indexed pages. That's why it says small. Small not by size, but relative to the content or to the overall size of the database itself. Crawler tasks. Question number 5. Do we have a question on 5, people? Crawler tasks. Do we have a question on 5? Okay. Number 6, peer-to-peer systems. It says, given a host or the host computers used in peer-to-peer systems, they relate to, or they often are desktops computers, okay, with users. Those users, let us say, that reside in an office or at home. The question is, what are the implications of this for the availability? This is one. And security, number 2, of any shared data objects that they hold, i.e. users, clients, and to what extent can any weakness, i.e. security breaches, be overcome using replication? So this is a security-related operating system question. This is a security-related operating system question, obviously, in a distributed system. Right. So what are the problems and what are the solutions? We'll start with the problems. Now, the first one says people often run their desktop computers off. They run them off or they turn them off, right? When not using them, obviously, even if they were on most of the time. Those are not used. They will be off when users are away, okay? And the time for such, it could be for hours, for an extended time, or the computer is being even moved, i.e. you take your computer from your office to your home and vice versa. This is one. The second one, the owners of participating computers are unlikely to be known to other participants. Obviously, those are just clients, okay? So their trustworthiness is unknown. Right. And now, having said that, with current hardware and operating systems, the owner of a particular computer or a computer has total control over the data inside this computer, obviously, and may change it or delete it at will. So what this is saying is that the relationship between clients or users are not obviously 100% a direct relation in terms of the two parties knowing each other. This is the case. The third point, which is the connecting point, it says network connections, i.e. between those users. So network connections to the peer computers, those are exposed to attack, obviously, including over flooding of information, aka denial of service, which is actually quite often happens with operating systems. So those are the problems that may be faced concerning on implications, or what are the implications for availability and security. So the availability and security concerns are there in terms of problems. Okay, so the importance of these problems, i.e. how they relate to the actual environment, it will highly depend on the application or what application is being used. Now, the more diverse the applications, the higher probability of an attack being imminent. So, taking an example such as music downloading, which was the original driving force for peer-to-peer communication, which isn't very important. This is just a queue for which you queue for your own download at leisure. Now, users can wait until the relevant host is running to access a piece of music. This is done at leisure. Now, there is a little motivation, obviously, for users to tamper with the music. Right. But, there's a big but. For the more conventional applications such as storing file or file storage, availability and integrity, these are all important, i.e. Problems number 1 or bulletin 1, 2, and 3. So this is, as I said, this is highly dependent on what sort of application we are dealing with. These are the problems for a so-called peer-to-peer communication. And now, for solutions, as far as the solutions, replication is the main solution. So, if data replicas are sufficiently widespread or available, this is in terms of spread/update. People, this is in terms of spread/update. So if data replicas are sufficiently widespread and numerous, the probability that all are unavailable simultaneously can be minimal or can be reduced. Okay, so this is one. For the second one method for ensuring the integrity of data, apart from point 1, one method for ensuring the integrity of data, integrity of data objects stored at multiple hosts, different hosts. Now, integrity relates to tampering or accidental error. Okay, is done by performing an algorithm to establish agreement. Now, this is just like a handshake. Again, this is just like a handshake to establish agreement. Okay, about the value of the data. Example, exchanging hashes. Okay, whatever username, password, and what have you, of the object's value, and compare them, just to make sure of the integrity of the data. However, again, it's a big but there is a simpler solution for this, for objects whose value does not change. Now, those are examples, many numerous examples, such as media files, such as music, photographs, radio. They are all have their own signature, and those signatures are consistent. They do not change, unless obviously they do change, but the time for that change could be months or even years. For secure hash identifiers, the object's identifier is derived from its hash code. Now, as far as those identifiers, the identifier is used to address the object, i.e. Just to make sure that this object is the right party. So when the object is received by a client, the hash code can be checked, obviously with normal integrity checks. This checking process corresponds to that identifier. Well, actually, it depends on how strong is that check is made. This is obviously, again, relative to what sort of application you are talking about. If you are talking about username and password for your banking system, it's different than when you're talking about your social media username and password, such as your Facebook. So it will depend on the strength, on how many tier levels or how many levels of hierarchy you go through in order to just make sure that such an identifier is the correct one. Number 6. Do we have a question on number 6, people? Question number 6. Surely you must have some questions, please. Come on, people. Anybody for a question, people? Right. Yes. Tornet is an example, sir. Yes, sir. Yes, you are correct. Anybody else? Karthik is writing something. Come on, Karthik. You started writing something. Don't stop. Oh, Nima again. I was hoping for Karthik to write something. But then again, it's okay. Yes, Nima. Just shoot. Aim and shoot. That's a long question, Nima. So can you explain, please, what is the simpler solution for media files? Now, the simple solution for media file, it is, well, we say simpler because if you go back to the problems, you see with music, it is rarely tampered with. So as far as the solutions, I mean, regarding bandwidth, this is one. Regarding the type of the file you are downloading, so it's bandwidth versus type of file versus time of the day of your downloads. These are only your concerns, actually. So as far as security, integrity, it will make the job of that provider much simpler because not so many people, or as far as tampering concerned, with such a channel for communication for that particular application is unheard of. Again, bandwidth requirement, time of the day, and type of file are your main concern. So this is a solution for such is not as stringent when it comes to file storage systems. Does that answer your question, Nima? We are talking about solutions for a much higher level of complexity as far as data concern. Again, I say, when it comes to media files, music, and so on, it is not that of a headache as compared to file storages. Right. We'll move to number 7. Now, 7 related to 6. This is related to 6, people. It says this the type of local resources that are vulnerable to an attack by an untrusted program that is downloaded from, let us say, a remote site and run in a local computer. Between brackets, we're talking about Trojans, viruses, and what have you. This is the essence. Okay, so the types of local resource or resources. First, objects in a file system, the type of objects, right? Network communications, the actual channel and link. And lastly, printers. Now, printers that might sound funny, but I'll explain why printers is included. Okay, so it says objects in the file system, example files, directories, can be read, written, created, deleted. Remember, with security there are a so-called access rights. Again, with security there are something called access rights. Now those access rights, as the name suggests, belong to particular and chosen clients. So objects in the file system, example files, directories, can be read, written, created, deleted, of course updated, using the rights of a local user. Local user as in that segment related to those clients who run the program. This is one. We are talking about security, right? Second, network communication, the actual channel. So the program might attempt to create sockets. Now remember, sockets, they relate to those interfaces that can be somehow, let us say, sniffed. Again, sniffed as in packet sniffing. So we are talking about packet sniffing, right? So network communication, the program might attempt to create sockets, connect to them, send messages, relay control signals, relay interrupts, and what have you. This is network communication. Access to printers. You see, with the printers, if when you send, let us say, if you send a list, a database person or administrator or a user is sending a list of the name of the clients belonging to a bank, a particular bank with their assets. Access to printers. While the printer is printing, whatever it is printing, such data might be diverted from that printer. That's why printers are dangerous, extremely dangerous devices. Now, I'm talking about environments that are somehow in a skeptical situation. I'm not talking about unloose environment. I'm talking about loose environments. So as far as accessing printers, I'm talking about the subject of this question is talking about how information to be printed can be diverted. That's why access to printers are included. It may also impersonate excuse me, the user in various other ways. For example, sending, receiving emails. This is just, those are used as test emails, and we are all under this burden of those emails. They do send you an email just to test you out. If you respond, now the first response will let them know that you are alive, you are there. You see, because there are so many accounts that have been created and never used. That's why you see periodically those accounts are to be deleted. It varies between 3 to 6 months. Anyways, so sending, receiving emails, those are examples of a so-called test email. They test you out, and then from that they might start a conversation. Excuse me, people. Question number 7. Do we have a question on 7, people? Excuse me. Sorry. Okay. Okay. Moving to number 8. Give examples. It says give some examples of applications where the user of a mobile such as Quinn and another guy, Reddy, currently they are using their smartphones. So it says give some examples of applications where the user of a mobile code is beneficial. Remember, a mobile code, it is just a piece of segment used for control purposes. Messages, interrupts, and what have you. Right. Now, these are used for first one, doing computation. Second, since they have some sort of a control purpose or interrupt purpose, obviously they'll be enhancing browsers. So doing computation close to the user, okay, such as Applet example. Again, this is a program designed to execute from within another application. This is an added application, right? Added application. With enhancing browsers such as to allow server initiate communication. Remember, control and interrupt. These are mobile code tasks. And lastly, cases where objects are sent to a particular process, and the code is required to make them usable, okay? Such as you know, RMI, which provides some sort of remote invocation for remote communication between programs that reside in your, say, your own device, using Java programming language. This is a Java platform. This is again a Java platform, RMI. So these are the examples of applications relative to the mobile codes. Remember, those are used for control, interrupt purposes. Sometimes synchronization, although synchronization is not it is not always the case, apart from voice over IP, real-time processing. But if you talk in general, you have to talk about real-time / quasi real-time processing and offline processing. Number 8. Do we have a question on number 8, people? Do we have a question on number 8, people? Excuse me. Yes, Nima. So what are the benefits of using mobile code? As it says, you see, if you look back at those points, you are talking in general, it facilitates communication. Now, to put your mind at rest, it facilitates communication. Now, the word communication is a large word, it's a big word. But instead of saying control, communication, synchronization, timely manner, real-time, offline systems, it facilitates communication. Does that answer your question? In general, it facilitates communication. Yes, Nima. Network communication facility as opposed to mobile code benefits. Right. Excuse me. Number 9. A question with a twist. Right. It says the twist is because it is a hypothetical case. So consider a hypothetical car hire company This is just an example. It can be applied for so many cases, so don't be bound with this example. Just generalize. This is a specific, it can be general example. Okay, so it says consider a hypothetical car hire after this consideration, and give a three-tier solution to what? To the provision of their underlying distributed car hire service. Now with car hire, starting from the first step of promoting a specific agency down to returning the car itself, right? So the service is provided from the first step, which is filling in the form, down to throwing back the keys in the box, or actual, if you're returning it in the weekend, or returning your keys and getting your money back, whatever you paid as a deposit. Right. So use this to illustrate the benefits and drawbacks of a three-tier solution, considering issues such as performance, one, scalability, dealing with failure, and maintaining the software over time. Now we are talking about a large agency, so scalability and software maintenance is of essence, or this is an issue. Right. So as far as those three levels, hierarchy of 3 levels, the three-tier solution might consist of, first, now starting with 1, then going to 2, then to 3. You cannot jump the gun. 1, 2, 3. So it is a web-based front end, let us say a GUI, offering a user interface, GUI, graphic user interface, for the car hire service. This is called the presentation logic. That's why it is a three-tier system, 1, 2, 3, and they should be running as such. A middle tier, supporting the core operations, i.e. the actual details associated with the car hire business, including locating a make, model, checking its availability or the availability and the pricing, and getting actually a quote and purchasing of this car. This is related to the application logic. And lastly, actual search in the database. So you need a database which stores all the persistent data, what is available, associated with the stock. This is related to the data logic. So first, presentation, second, application, third, data logic. 1, 2, 3. Three-tier. Performance. So in terms of performance, we are talking about the distributed system, a distributed software, interaction between a client and a particular organization. So performance is an issue. In terms of a performance, this approach introduces latency or extra latency. Related to what? In that request must go from web-based interface to the middle tier, and then go to the database and back. Back as in an answer, because submission from a client needs an answer from the organization back to the client and back. However, processing load is also spread over those 3 machines. Although the spread is not equal, I will come to that later, but processing load is also spread over these 3 machines. especially over the middle tire. Now the middle tire is the actual part for which all the questions given to the client is to be interrogated and put in such a form so it could be presentable database wise to tire number 3. Okay, that's why it says especially over the middle tire and the database. Okay, and obviously this may help with performance. Now, how stringent is this process is, the more elaborate it is, the lower performance will be. However, if somehow they have, or the organization have included some sort of keys or indices that can look at particular groups instead of one group, this will make things much easier. This is related to strategies, right? So this will help in performance. For this latter reason, performance, we're talking about performance, the 3-tire solution may scale better. It will scale better as far as if you somehow in the second and the third level, i.e. The application logic and the data logic, if things are made more organized as far as dissecting or making the availability of whatever, let us say cars here, in groups. You see there are so many groups as far as maybe colors, engine sizes, make as in type and year and so on. Okay, so this may be enhanced through by other, let us say, complementary placements strategies, including replication. Those are replicated when you look at, so let's say, an engine of a 1.6 engine or a 3.8 liter engine. Now you'll see a different make of the same engine, but then again those different make can lead you back, once chosen, they lead you back to a particular group instead of going back straight to an origin of a group containing all make of a 3.8 engine car make. So in terms of failure for such partitioning aspect, there are an extra element involved, and this increases the probability of failure if there is no such partitioning. Okay, this will occur in the system and it will delay the system. It will not collapse the system, it will delay the system. Equally, failures are more difficult to deal with. For example, if the middle tire is available and the database fails, i.e. In terms of the submission of the actual application is done while the database itself fails for some reason or other. In general, the 3-tire approach is much better for evolution, i.e. For a progressive evolution, as in a progressive processing, because of the intrinsic separation of those concerns. Now, there are 3 tires, each level is abstract from the other, i.e. You have outputs from one tire to the other only just to make sure that the tire below or the level below needs those information and only those information. This is related to efficiency. Okay, it's giving you an example. For example, middle tire only contains application logic, i.e. applicable to what a mode of information being done in the presentation logic, and this should therefore be easier to update and maintain. Now, updating and maintaining depends on what goes in and out as far as car make, sizes, colors, and what have you. Question number 9. This is an example. Do we have a question on 9? Now make sure that this example is related to car hire system. It can relate to other applications. Do we have a question on 9, people? Okay. Again, before I go to 10, this example shows how you organize yourself as an institution so that data propagation, information propagation can be managed. Okay? It is divide and conquer. Divide and conquer. That's why such is initiating this three-tier system, divide and conquer. Right. Number 10. Now, number 10 is on Schulz's end-to-end argument or arguments. It says, provide a concrete example of the dilemma, a problem, of a dilemma offered by Schulz's end-to-end argument in the context of the provision, the allowance. How do you allow a middleware support for a distributed system applications? Now, it's giving you a hint. You may want to focus on one aspect of providing dependable distributed system. Security, people. We are talking about security. For example, related to fault-tolerant security, which is extremely important. Right. So what is this end-to-end argument all about? Sauter's end-to-end argument states that links or communication related functions can only be completely and reliably implemented with the knowledge and help of the application, i.e. the application must provide the right resources for this channel to be correct, and therefore providing that function as a feature of the communication link itself or system itself, or middleware is not always sensible, i.e. this should be done in a controlled way. It shouldn't be done in a spread way. You cannot spread such, in particular, such control scheme. So one concrete example, again, we are talking about security, so how security is maintained. So one concrete example is in secure communication. Right. So we are assume that in a given system, the communication subsystem, okay, not itself, the communication subsystem, provides encrypted communication, i.e. within the system itself you have encryption. So this is step one. Assume that in a given system that this subsystem, when encryption is provided, this will naturally be helpful but insufficient for the reason of tampering or an intruder. So this is helpful but insufficient. For example, the pathway, the link, the channel may be tampered. Okay? The pathway from the network to the application software may be compromised. or tampered. Compromise means tampered. Okay, and this is unprotected. Okay, so this solution also does not deal with malicious participant in the exchange of data because you might have invalid participants. So it will give you an example. So consider also the reliable exchange of data implemented by introducing checksums. So checksums might help, i.e. Encryption plus checksums. Okay, checksum protection. A CRC is an example. Cyclic redundancy check is an example. So those checksums on individual hops in the network. But again, you have a problem. Again, this is insufficient as data may be corrupted by intermediary nodes. Remember, in our first visit, we had A and B. Remember, C was in the middle as a hop or a transient proxy or router. You might have tens of those hops. One of them might fail, or somehow your data might be corrupted. So as far as those hops, this is insufficient as data may be corrupted by intermediate nodes, for example, nodes as in gateways or the end system itself. So as far as this Sulzer's end-to-end argument, what it is saying that 100% reliance on encryption, CRC, okay, and the actual link itself does not guarantee that data will be received correctly. So you might think, okay, so what is the solution? That's why you have people, that's why you have acknowledgements, positive, negative acknowledgements. That's why you have relays or relayed messages, or messages to be sent once or twice. And this is why, excuse me, your internet is based solely on error detection, never detection and correction, because of this argument. This argument actually provides some evidence that which is why the internet is based only on error detection, never detection and correction. Question number 10. Do we have a question on 10, people? Okay. 11. This is a simple question. The reason for this question 11 will be apparent in 12 and 13. Okay, so it says consider a simple server that carries out client requests without accessing other servers, i.e. this is a loner server. Carries out client requests without accessing other servers. Okay, explain why it is generally not possible to set a limit on the time taken by such server to respond to a client request. Don't forget, this is a server that is acting by its own and only itself. What would be needed, or what would need to be done to make the server able to execute requests within bounded time? Bounded time as in somehow known time, between brackets realistic time. Is this practical option? We will see. Okay. Now, first thing you have to know is number of users, type of applications. First, you have to think about number of users, types of applications. So the rate of arrival of client requests is unpredictable, obviously. So if the server or the mechanism for this server, if the server uses threads to execute the requests concurrently, it may not be able to allocate sufficient time, right? Concurrently, because concurrently means that it will have somehow time slice. Again, concurrently mean that it will have somehow time slice its own processing time to service those requests. Once this time slicing is to be done or is done, you will somehow miss a fraction of time depending on, again, remember I said number of users, type of application / applications. So it may not be able to allocate sufficient time to a particular request within a given time limit, time slice. Time limit, time slice. If the server queues the request and carries them out one at a time, they may wait in the queue forever or unlimited amount of time. So slicing has got a disadvantage. Queuing is a disadvantage by itself. Right. So to execute within bounded time, this is the solution. Limit the number of clients. Limit the number of clients. But we said that number of clients, type of application / applications. Remember this. To execute requests within bounded time, limit the number of clients to suit its capacity. This is to deal with more clients, right? Use a server with more processes, a bigger capability as far as processing power. After that, or instead, replicate the services. Now, service replication, this will mean that there will be an available copy of a currently, listen carefully, there will be an available copy of currently requested service by previous clients. So those copies must be buffered. Again, those copies must be buffered, put in a queue, and as time goes by, this buffer or this allocation of buffer for those clients or previous clients that requested those services will somehow be managed, because as you know, some of those clients or the clients that requested a particular service, other clients might not need such. So in that queue, old or unwanted services will somehow be dissolved or deleted. So you need a higher power of service in relation to the processing power. You need a higher power of service excuse me, as far as the provision of buffers. That's why you have a so-called front-end processors. Front-end processors or cache processors are the main theme of this question, right? Front-end processors or cache processors actually will deal with such. Although currently front-end processors are used as a first defense for just like as a hardware firewall, but they could also be used as buffer areas. So the solution may be costly since you have to spend money, right? And in some cases, keeping those replicas consistent, i.e. updating, may take up useful processing cycles, i.e. the processors or well, processor slash processor or processor slash processors must maintain those replicas. Question number 11. Do we have a question on 11, people? Okay. Question number 12. Now 12, it says for each of the factors that contribute to the time taken to transmit a message between two processes over a channel or communication channel, state what are the measures needed. The essence of this is we are talking about quality of service. I'm just giving you the theme, quality of service. So it says state what measures would be needed to set the bound or a bound on its contribution to the total time, processing time obviously. Why are these measures not provided in current general purpose distributed systems? So we are talking about the quality of service. Now by definition, the quality of service relate to how good is your system as far as performance slash scalability slash applications. So quality of service relate to scalability, performance, and applications. Now we are talking about the best of performance, the best of scalability, and the best of availability of applications. Okay, to answer 12, time taken by OS, the operating system, communication services is as thus: sending and receiving processes. These tasks would need to be guaranteed sufficient cycles or processor cycles, i.e. they should be maintained. Somebody must look after those, i.e. you should have a particular thread or threads that look after those communication interrupts or control signals. So time taking to access a network with a pair of communicating processes would need to be given guaranteed of network capacity. Again, we are talking about quality of service, network capacity, scalability. Okay, number one was on performance, 2 on scalability. Right, the time to transmit the data is a constant once the network has been accessed. Now this is actually related per session. Now if you take an average throughout the 24 hours cycle or throughout the day, this is not true. But throughout a session, this should be true. Why? Because you might be dealing with real-time applications, and with real-time applications, you have to set a time. Now, with real-time applications, obviously you have to guarantee, or you give guarantees. What type of service? What sort of application? Let us say that we are talking about video conferencing. Video conferencing guarantees such as quality of voice, quality of resolution. If you are talking about high definition outputs, wow, you'll be needing a high bandwidth to carry out such in terms of video slash audio. So it says constants once the network has been accessed. So this is related per session, people. This does not mean for the whole time. Excuse me. To provide the above guarantees, we would need more resources and associated costs. Resources, this relates to hardware and software. Resources, again, this relates to hardware and software. Examples: operating systems, real-time operating systems, software. Hardware, processors, i.e. number of processors, multi-cores. Resources and association costs. The guarantees associated with accessing the network can be, for example, provided by ATMs. Now, ATMs are, they have been available for the last, 20 years now? They've been available since more than 20 years, actually. Late 90s. Okay, now ATMs are good examples for providing good QFS, or quality of service. It relates heavily to number 12. Okay, but the problem with ATMs, those are very expensive. ATMs relate to asynchronous transfer mode. It has nothing to do with auto-teller machines. Asynchronous transfer modes. Base machines used for channeling, actually, they are used for as local intermediate networks, and obviously they are used for channel capacities as far as telephony, video conferencing, and what have you. Okay, so those are expensive for use in LANs. Now, to give guarantees for the process is very complex, is more complex. For example, for a server, guarantees to receive and send messages within a time limit or bound would mean limiting the number of clients. Again, we are back with a number of clients. The more you spend, the better the performance is. So QFS is related to the machine, the actual machine to be used, and how advanced is your machine. The more you spend, again, the more applicable is your application related to real-time processing. This is, in essence, talking about real-time applications. Question number 12. Do we have a question on 12, people? Question number 12. Do we have a question on 12, people? Kim says no. Kuta says no. Okay. 13 related to 12. 13 is related to 12. It says the NTP, or network, excuse me, network time protocol service can be used for synchronization. So it is used to synchronize computer clocks. We're talking about A and B, A transmitter, B receiver. Right. Explain why even with this service, no guarantees or no guaranteed bound given for difference, or for the difference between those two clocks. So you will somehow have a so-called mis-synchronization. Okay. So, simple answer for this question. Any client using such protocol, an NTP service, must communicate with it by means of message passing, or message passed over a communication channel. Obviously, this is obvious. Now then, the problem is, if a bound can be set, okay, i.e. time limit, if a bound can be set on the time to transmit a message, i.e. the time for the message to be sent and received, the latency, okay, from A to B, over a communication channel, then the difference between the client clock and the value supplied by the NTP service would also be bounded. i.e. is just a simple addition. You set a time, you add the propagation delay from A to B via a channel. Those could be calculated easily if it is a wired excuse me, if it is a wired channel such as a UTP or STP, coax. Propagation delay can be calculated through its or through the normal mathematical model for that copper link, or if it is a wireless link, resistivity and the environment itself can also be contained somehow with experimental time delays, i.e. propagation delays, and those can be added to give a factor that is included to the NTP. Right? So with unbounded message transmission time, clock differences are necessarily unbounded. So what, in essence, what this question is saying is that how do you calculate or how do you include the time for the propagation delay, i.e. from A to B? Obviously, if you are having messaging between A and B, you'll expect B is to be now a transmitter, B is a receiver. This is just a ping-pong situation. A is talking to B, B is answering a question. It could be an acknowledgement or it could be a lengthy message. By all means, if this is to be done, this propagation delay should be added and included so as to know how long the message will take actually from A to B. Now, people might ask why this is important. Don't forget that if A sends a message to B, B needs to synchronize its clock so it can sample the received data. This is a communication must, i.e. it can sample its data, i.e. it must know the start and end of the message. This needs synchronization. B must be synchronized to A. F equals 1 over T. If T is known, the frequency is known. So if F is known, sampling or sampling frequency can be dictated at the receiving end, whether it is A or B. Question number 13. Do we have a question on 13, people? Okay. Number 14, checksums. Now, 14 says, consider two communication services for use in asynchronous distributed system. It's not synchronous, it's asynchronous. It's giving you two services, A and B. So in service A, messages may be lost. This is 1. Duplicated, this is 2. Delayed, this is a 3. And checksum apply only to headers. It does not apply to the actual data, only headers. Now the reason why I apply it for headers, only headers, just to make sure that the source and destination are correct. Right. Now, for each of you, I'm going to ask you a question, and you should answer me. For each one, I want you to write a possible checksum algorithm. Just the name. I'm going to give you 2 minutes. Just write a checksum algorithm, just straight